From professional services to responsibility sharing, a counterintuitive approach to customer reliability engineering. I'm Joshua Fox. I'm a senior cloud architect at DoiT International. And that means that I help technology companies with their problems in Google Cloud and AWS, everything from defining their architecture to helping them with terrible system crashes. That's what I do. I have a bunch of certifications in both Google and AWS. I'm also a Google developer expert, which means I travel the world and talk about Google technologies. Although this one is not entirely about Google technologies, it's about the cloud. Let's talk about a case study of growth pains, something that we deal with, which is the best kind of pains to have. And a lot of companies in hypergrowth have to face this problem. So we'll talk about Siraxis Technologies, that is not the real name, a fintech software as a service. They were founded in 2016, and they've been doing very, very well since then. Exponential growth. You know, when you're undergoing exponential growth, it looks like nothing's happening. And then they say there's an elbow in the curve and you shoot up. Of course, that's not true. It's a derivative is quite continuous, but things were doing well, but they really got beautifully out of control around 2020 as the company started growing every single year, several fold. So they were having ×3 annual revenue, and that meant they were hiring a lot more people in line with that revenue. Also, their cloud costs went up perhaps 4 times, more than 3 times. This is happening year over year to this fintech company. And growing and growing and growing and growing. Does it ever stop? Let's see. Well, where it stops. Site reliability engineering. So when a system is growing so much, and when your customers are relying on it for financial technology, you've got to keep the system going. And the technique is called SRE, which means that you run your operations in the cloud using automation as much as possible. I'll get into more detail about what SRE means as compared to other methodologies. The team had a sysadmin background, so they're technically strong, but they started on premises, which is very different working environment from the cloud. And just to understand these terms like sysadmin, we'll talk about SRE, we'll talk about other terms. Historically, sysadmin was one engineer working on this one machine. And I've seen people whose job was one database, not a very complicated database either. Restarting when needed. If it's Windows, it's often through a GUI. Maybe I'm exaggerating. There were always very skillful people out there. But that's what the sysadmin used to be. And for on-prem, when only a few computers, that's fine. So, however, some of them had a more sophisticated background, moving into operations. Operations is like sysadmin, but with more computers and defining a work process, defining a workflow. So it's not just the one guy pressing restart on his Windows console. It's a run book. It's a system of working through the entire company where different engineers can collaborate. You know, it was said at the time that the sysadmins are going to lose their jobs and maybe there will be only a very few people left. But what happened was that the number of computers being managed shot up so that, yes, you need fewer sysadmins per computer, but there are far more virtual machines or other computing systems out there, whether it's databases, virtual machines, or anything else. And moving on in the history that these people, again, had experience with into DevOps. So DevOps pushes operations to the left, and it says that often the same people who do development are responsible all the way through to releasing, often with a continuous integration, so that when they write some code and push it, it gets tested all the way through and ready for deployment. So that's the next historical phase. When I say that they ran into trouble, you know, I don't mean that they lacked skills, but they did have this historical background, and we're going to show how they move forward and build the skills beyond that. Now, the next level, which I guess nowadays is the fashionable term, is SRE. So as they moved into the Google Cloud, they developed their financial system using a fire hose of data over PubSub with a Kubernetes cluster and all wrapped up in private networking for security, which is needed. Istio creating an internal service mesh. The details of this don't matter because this is more about how they organize themselves. But the point is that these are modern cloud technologies that require a different way of working. And SRE, what does SRE mean? Agile development methodology. In Agile, you're continually releasing. There's all sorts of subvariants of Agile, of course, but the key is that you're moving quickly, continually releasing, automating everything as much as possible. And in the case of SRE, it means that if something goes wrong, you figure it out and then you automate how to fix it the next time, how to keep that from happening the next time, so that you do not have the engineers at 3 a.m. pushing the restart button. And the team figured that out. They're working with that too. And they have these skills in-house. So they're building out and learning SRE and figuring out in-house how to work in the Google Cloud, even though their experience is mostly on premises. This is a journey that perhaps you've all done. In fact, maybe I'm telling you old things you all know, of course, as you've all been through many of these stages. But everything was looking good as they learned and learned and learned, but they still have more to learn. And the cloud is enormous. The cloud is almost like all computing is the cloud. So you cannot know it all. You just can't, even if you're super expert, you've learned all these different systems, there's always missing information and there's just too much to learn. And especially for people who, as I said, did have a background in on-prem, yes, they learned, but that's where their training, their experience mostly comes from. So this is where they hit the weaknesses of their weaknesses as they work with the cloud. And that's what I'm going to explain to you, how they overcome that. It is not easy. I know that I personally, in my background, was an architect on certain products. And of course, I learned certain technologies in great depth. I mean, I was in touch with the Google App Engine Flexible Environment team, telling them where their bugs were. I understood it better than them. So you could say, oh, I knew it in great depth. Yes, but how many technologies were we using in my company? 5, 10, I don't know, whatever the number was. There's no way you can comprehend all, whatever the number is, several hundred services available in Google Cloud or AWS, and furthermore, to comprehend them in depth. So as a company that's moving fast and wants to learn, they cannot learn fast enough to keep up with their very beautiful speed, their very beautiful growth. So one way to solve this problem is by hiring. And I'm not painting doom and gloom. There are people out there that you can hire, and they have skills. And Siraxis was able to hire people. But again, they know what they know. They have experience in a certain thing. They can learn other things. But you're not going to cover the full breadth of everything you might possibly need to know in the cloud just by hiring. There are some people out there who have this breadth, but they probably don't want to work for, just this one specific application. It becomes very, very hard to hire them in order to provide that coverage and give the team the breadth of knowledge that it needs. Okay, how do you resolve this? And because I am talking about learning and growth, we'll talk about a new microservice that Siraxis was building. So yes, they have to go to the next step. They have to learn more. And this is a financial analysis microservice. It's receiving a very fast stream of financial quotes over PubSub. And as I said, processing with the technologies Kubernetes, Istio service mesh, and taking care of a private networking. And they have to build this. So they cannot deal with the growth. It's just too much for them to handle. They can't hire fast enough on the top skilled people. So one solution, which they tried, was to hire outside professional services. Sounds good, because a ProServe company can, in theory, bring you the full breadth of skill across everything. It's big enough, they can cover everything you could possibly know. So you buy the knowledge from the ProServe as they do this for you. Consultants are outsourcing. Somebody says they're a consultant, watch out, because often it means this is hands on keyboard, like you bought another body. Okay, that's a wonderful thing, you know, valuable professional skill. But you have to think carefully what you mean by professional services. Does professional services mean a wise counselor that comes in and exactly fills in those blanks that you have in your company? Or does it mean warm bodies, which has a value in itself, but not necessarily in the top skills? So the ProServe does the first thing, which is to architect a beautiful solution using the cloud the way it needs to be used. And they do have the skills and the knowledge to do that well. And further, remember, this is a new microservice. Siraxis has already maxed out their abilities. So the ProServe deploys it, creates continuous integration, continuous deployment, which I mentioned CI under DevOps. CD, you can call it part of DevOps or not, it doesn't matter. But CD says that the developer pushes code to the master branch and a new version is released publicly, in production, automatically, several times a day. So that's the newest way to do it. It sounds scary when you're dealing with finances. I couldn't believe that it was even possible when I first heard about it. But it allows you much more velocity, and surprisingly, it allows a level of quality because it has to work right. You've made it so that, well, if it doesn't work right, you're in trouble, but it requires you to polish the automated system so that you don't have a person pushing the deploy button or something like that. So it requires the best of you. So that's what ProServe does. Now, as the next step, and here we're talking about all the phases of handling a production system, monitor and maintain it. So you can hire ProServe to do a 24/7 operations center, and they'll put people on the monitoring dashboard and deal with it. And further, as you know, all systems are live. There's no such thing as a static system. Whether it means there's a crash and you need to deal with it, whether it means there's a change in an underlying library and you need to change your own system to deal with the underlying services, or whether it means developing new versions and releasing them. Systems are always live and living things, so you can have ProServe do that for you too. Well, you can probably guess I'm going to tell you the problems. I just said three things that ProServe can do. But what are the problems with it? First of all, it's expensive because you're paying the salaries plus the overhead, and they have to make a profit margin, management, negotiation, statement of work, project managers. So you pay a steep overhead for the flexibility of being able to pull in that expertise from an outside company. And hundreds of dollars per hour, depending on the skill level of the individual who you're hiring. But money is actually not at the center of what I'm talking about here. One important point is that they do a less than thorough job, and Siraxis asked for that. Siraxis has an incentive to tell them to do a bad job. Why? Because it just costs so much, and everybody knows that. So get a system working. That's enough. Stop charging us more. Everybody understands why that's a problem. There's no doubt about it. But what choice do they have? They can't tell them to keep polishing it forever. It's not even clear what that means, to keep polishing it forever. So you get a system that just barely works. And that's what happens when you have an outside team who takes any sort of responsibility for something that really belongs to the company. The next issue involves skill set. So it's famous that you negotiate and then you talk to the senior architect. And then as soon as they come on, well, you've got the lower skilled people. And you know what? That's not a trick. Siraxis, the customer wants that in a way, because they don't want to pay the top hourly rate or anything like that. So I just introduced this as saying that they have a skill gap, and they're not really going to fill the skill gap. They'll get people who've been trained in the specific technology, what's needed. But if you dream of covering the cloud, well, you're not going to get people who have that breadth of knowledge working on a regular basis to fill in with that depth of experience and wisdom. And this also means that the experts are less available. Previously, I just said you have the people who are less expert and architects disappeared. You don't want to pay that. But on a more practical level, if I need an expert, I'm willing to pay. There's no way that they can be allocated by their management to, unless you really spend a lot of money, they can be allocated by their management to be available to you when you need them, as you need them. And further, when I say available, that could mean, please schedule us a meeting tomorrow, but it could mean 24/7 things are going down. Nobody has any idea why, including all of these people sitting at the network operated center. We need a true expert. It's just not possible. The finances don't work out that way. So I just said a bunch of problems with this model, but we've now built up to the single worst one, and that is responsibility. When you develop a system, you care about it, you fix the bugs. Professionally, you care. People do care about their work, including the professional service people. But the question is, whose mind is this sitting on? By the way, we get an echo here. Yeah? Maybe there's another audio on the room. Should put a mute. Something. All right, or maybe even take it out of the room or something. I don't know. Okay, so when you build something and you care about it, and let's imagine the poster people, they're professionals, they really care about their work. But Siraxis knows nothing about it. It's not enough to have a knowledge handoff. We know that doesn't work. Yes, you talk to somebody, you have a meeting, you have a document, but that depth of understanding of this is why things are working as they are only occurs when you or your team is hands-on, building, responsible for every stage, from development through deployment, through to monitoring, handling incidents, maintenance. So that is actually the single most important point I have to make that we're going to think about in a minute. Now that I've built you up to that, let's talk about the other way. CRE, Customer Reliability Engineering Advisors. What they don't do makes the difference. So the key here is going to be certain things that the outside advisors refuse to do, even if you pay them for it. They're not going to do that for you, no matter how much you want that. And Siraxis actually was able to move forward by having people who would not do certain things for them. So let's talk about how that works. Customer Reliability Engineering. So CRE is a term made up by Google. Maybe they invented SRE too, I don't know. And as always, the term means different things for different, it doesn't matter what other people think it means, but Google used the term CRE to mean they would help you with your cloud, like that hands-on. They'd actually do work at no charge, but you'd have to commit to Google level quality, which is actually very expensive. We all like quality, but that's expensive to really polish your system up to that level. But okay, if that works for you, then that's what Google would do in some cases for some select customers. That's one meaning of CRE. Another meaning that some companies use is pretty much what I already said a few minutes ago, which is that they just do hands-on work. So that's not what I'm talking about today by this phrase, customer reliability engineering. And actually, this is embodied by my graphic here, where you see that Siraxis is closer to the cloud system. CRE is hovering out there behind them. They're not between the customer and the system, but rather the customer is working with the system and CRE is outside and advising. Here is what a list of what they do and don't do. So the CRE advisors will review architecture, design, or even problems in a running system, discuss it with the customer. Siraxis, tell it, what have you found? What are your questions? What are your problems? They'll analyze. They'll say, I'm looking at your architecture. Maybe you should do it differently. I'm looking at your crash system in production. Here I'm figuring out where the problem is with you. And then they will suggest to Siraxis how to fix it. All that's cool, but here's what they don't do. They never author anything. The CRE will never author anything, never implement anything, never deploy anything, and never fix any problems. Let's see what that looks like in more detail. Of course, you may have heard of the shared responsibility model. So I think AWS invented the term. They say AWS is responsible for the cloud and the customer is responsible for things running in the cloud. So that's a good way to think about it. And then it's important to see the CRE as kind of standing in the middle, on the side, but in the middle, saying, you, Siraxis, are working in the cloud. You don't understand the cloud, which AWS or Google is responsible for. We'll help you connect to the cloud, mentally connect to the cloud, potentially connect to the Google or AWS team as well. Yeah, but still not being that intermediary, but still not hands-on. Everybody loves the term hands-on. Sounds nice. But sometimes it's better not to be. So the CRE will not implement any code at all, not any YAML, maybe for a POC, you can send a snippet of code that just says, here's an example, but it's not meant to run. You're not meant to use it. It's just a way of communicating. No code at all, ever. The CRE do not touch infrastructure. So you give them read-only permission because they have to see your system and find the problem. But absolute, if Siraxis is under stress, things are going down, something's very complicated to fix, and they say to the CRE, just go fix it, it'll take you a minute. No, absolutely not. Very important to have that permission that's blocked. You can make corporate policy that say for security, we absolutely refuse to take write permissions. And that is not just for security, it is security, but not just that. So no one likes to talk about refusing to do work, but in fact, this is a very collaborative model because it says that the people who do the job are going to be SRE from the customer. And the CRE advisors from the outside has got to work with them. It could be email, a ticketing system, and video calls where you can jump on and do screen sharing, effectively do things together, but not doing them together. The CRE is telling or advising the SRE what to do. So this is, because each one has a definite responsibility in the shared responsibility model, everyone benefits as they collaborate. An advantage here, an advantage of this system is that SRE gets the best people and they themselves become the best. Oh, Siraxis in this case got top experts. That means that they can talk to architects who know the cloud side to side, backwards, forwards. And as I said earlier, that's not really practical if you have armies of lower skilled people doing the implementation for you. This is just a small team of advisors, of consultants, and they're on tap as needed. But let us not forget the CRE advisors themselves. Note the smile on their faces, because they have the opportunity to share their knowledge, share their experience, and not be responsible. That doesn't sound good to have responsibility. Yes, Siraxis has responsibility. Meanwhile, CRE's responsibility is to make Siraxis happy, to guide them through, to solve them for it. So it puts, everybody gets stressed out, but it makes sure that the CRE people have that responsibility of helping. And also it makes them happy because they do get that to explore that breadth of knowledge across that they may have built up over many years of experience. These are top people. As I said earlier, if Siraxis tried to hire these people, some super expert, this person will be working on PubSub, Kubernetes, as I said earlier, just these few technologies, which people on that level maybe don't want them. Everybody enjoys different things, right? But this gives the CRE happy. If people are happy, then the other people are happy too. SRE of Siraxis is building the skills. They never say to somebody else, you do it. They say, I'm doing it. I'm responsible. They are responsible. It's their company that's going down after all. They're the ones with the employee stock options. So because they learn hands-on as they are guided by CRE, everything they do is a learning opportunity. And they're growing their own team to get that depth of knowledge in the cloud that they just wouldn't have otherwise. Oh, and the talk of when somebody's pitching their great idea, right? Like I'm telling you this great idea, it's important to say what the limitations are. You got to be good. Siraxis team has to be top skilled technologists themselves. I said they came from on-prem, they learned the cloud, but they have to be engineers who can take responsibility for everything. This is not going to work if you have a team of people with no skills, because the CRE can only tell them what to do. And ultimately, you need to have the professional ability and insight to do it yourself, yes, with some help and guidance. So that is a strong limitation on how this system can work. It probably won't work for a lot of companies for that reason. Probably only technology companies and not old line companies that you basically what we call digital native. The benefit is that the system stays in the hand of SRE because it's theirs, because they're going to have to suffer the on-call when it goes down forever. They do a thorough job. And they understand the trade-off. Sometimes you can't do a perfect job, but that's a trade-off too, that they absolutely understand with no need to negotiate, but rather based on their company needs. You get a much higher quality system by breaking that additional chain of communication and passing the buck. Another advantage is that top people can be available 24/7. When all you're doing is calling them for occasional advice and not to work down in the code mines, then it requires less of their time, and therefore they can have that flexibility of being available when things go down at 3 a.m. on a Sunday, especially if their CRE team is spread out all over the world. And ownership, as you understand, stays in-house forever. That sense of deep professional caring about the system. The only person to get angry about the bugs is yourself or your teammates. So that's what happens when you keep the responsibility in-house. The cost is far, far lower, of course. I told you why ProServe is expensive. Actually, we at DoiT don't charge anything, which is incredible. But that's because the Google or Amazon gives us a big wholesaler discount on cloud on the fact that our customers buy the cloud through us. They basically don't pay anything at all, actually. So it's much lower cost, but that was only possible for Google and AWS to do that because, as I said, it is cheaper than ProServe. Otherwise, there's no way they could fund that, as it were. Well, the disadvantages of the CRE model. Let's walk through an incident of rapid response and see how we handle that. The other half is designing architecture. That's another thing, but we'll talk about incident response. The system is down. Traffic is not arriving at the Kubernetes cluster. Something's wrong with it. Istio maybe, but nobody can figure out why. Yes, these people built it. They're not the world's greatest Istio experts. And 5 minutes. Okay, so how are they going to handle that? So first of all, they try to analyze for root cause and they're not able to do it. So as you know, with incident management, you have a person who's in charge of the incident, communication to the CO, to the customers, but also in this case, they use the runbook and they open a request to the CRE. And because of the read-only permissions, which I mentioned, the CRE is able to immediately start to analyze in parallel to SRE. SRE has no time to talk to anyone, but they will in a minute because they've each had a look at the logs, at the monitoring tools, and they get on a screen share call. And at this point, the CRE is able to say, you forgot about this monitoring tool. Did you even know that you have this metric? Did you know that Google Kubernetes engine has this built-in dashboard that you can use? And together, they explore the data in a screen share and go into depth. And at this point, they see that there was a misconfigured YAML configuring the outward-facing Istio service. It's actually pretty simple, but it's always scary to deploy into production. So they discuss it together. And then, of course, the last arrow is just Siraxis, who actually does the fix. If they need to, they can ask in a screen share, please look at what I'm doing. But once it's been explained, they can probably handle that. SRE comes out of there with the thing that they most wanted, which is to handle the crash. But also, they come out with knowledge that they now know what happened, what to do better next time, how to work with that. So great talking to you, and we'll be taking questions at the end, I think. That's what I was told. Is that right? Yeah, I think I was told that after the 3 talks, we'll take questions. Here is a bit.ly. You can, if you want to take a photo of the QR code, or bit.ly CRE-experts is the same thing. And that will lead you to this slideshow. And you see my email as well. So I'd like to hand over, please.
Anyone need more time for this? No? Okay. What time does the beer finish? Very important question. Is it 30? Okay, so I can't promise that so we can't extend it by a few minutes, can we? Otherwise, I recommend you really grab a beer like now, really fast. Otherwise, yeah. But, how do we? Oh, and I'll need to get one too. Sorry. While this one is loading, I'll grab one. Yeah. All right. Sorry, we're running late. That's yeah. That's why I can't promise. I'll try. Anyway, there's beer outside. If you need to go. Okay. Cool. Can you see my screen? No, can't. Someone else is sharing their screen. That's why. Can you click that button there, please?
Okay.
Okay, cool. So my name is Birger Halfmeier. I'm a senior cloud architect or a CRE, just like Joshua. If you can't tell from my accent, I'm German, but I do live in Melbourne, Australia. I was really excited to meet some famous LinkedIn celebrity with like 200 certifications here tonight, but he's not here. So anyway, it's nothing like what he's got. But yeah, I do work in the cloud and I know a little bit about it. Okay, so I'm going to talk to you about cost and specifically about cost in the cloud. So first of all, who here is everyone using a public cloud like Amazon, Google, Microsoft? Anyone not using the cloud? You're not. You're like fully. You are okay. Good. Okay. Okay. Just like really, just curious. How many use AWS? And okay, so that's the majority. How many use GCP? Few. Azure. Okay, also slightly bit less. Okay. Anything I have forgotten? Like Aliyun. Okay. Any other? Yeah. Okay. Anything else like a DigitalOcean? What is that? Sorry. What are they called? UpCloud. Okay, cool. All right. Okay, cool. So there are others, but either way, so whichever one you're using. So if you're using a public cloud, you're getting a bill probably every month. Who here actually looks at their bill? Or have you ever looked at your bill? Has anyone not ever looked at their billing data at all? No, so you do. Okay, you know you're doing stuff. The stuff that you're doing in the cloud costs money, right? So every month you get a bill, and it tells you a few things. Obvious one, it tells you how much you have to pay. I know that's really boring, but it's important. If you don't, pay your bill, there will be consequences, and there'll be other stuff that your accounting people need to know, like taxes and credits and discounts and whatever stuff is on there. Again, not too interesting for us technical people. But where it gets a bit more interesting, it actually tells you what you are being charged for, like what services you are consuming in the cloud. And that can be a little bit interesting. And in general, it also tells you when and where those services were consumed, except when it doesn't. Can anyone think of an example of like a line item that they've seen on their cloud bill, like a charge that's not directly related to a specific consumption at a specific point in time and location? Yes, no? Sorry? Networking, it should still sort of tell you like it's egress from a certain region, and what it would tell you like at least a day, maybe it's not down to the hour, but persistent volumes. I would think it's the same thing, wouldn't I mean, yeah, you won't see like every single volume, but yes. No, I was actually thinking more of things if you have any sort of commitment, right? Like if you're paying for like a reserved instance, or you may not actually be using it. You'll still be charged for it, even if you've stopped using it. So, but yeah, in general, you can actually see what you're using on your cloud bill at a high level, what services you're being charged for. On its own, like just in isolation, if you just look at your cloud bill by itself, so it's not going to tell you what you actually did with those services. So, your finance person might say, hey, I saw this thing on the bill, like, why are we paying for this thing? What is it for? Your cloud bill doesn't actually tell you that. You need additional context or information or understanding of what your business is actually doing with these services to answer that question. And it's also not going to tell you if you're actually getting good value for money, because first you need to know what are we using the service for, and then you need to know, okay, how valuable is that actually to us? And then maybe once you can answer that question, then you could also work out, okay, could I be spending less and get the same value? But your cloud bill is not going to tell you that on its own. You need to look at it in the context of what you are actually doing in your business. And there are some ways to make that easier, which we'll touch on. Also won't tell you how well your business is doing. In some cases, more cloud spend actually means you're doing well. Like let's say you have a really successful app, you're getting a lot of downloads, a lot of hits to your web service, which means you're horizontally scaling, and then it's actually great. You're paying for more compute because you've got more customers. But it may not be that. So your cloud bill, again, your cloud vendor doesn't know if you're actually doing well or not. They just like, okay, you've consumed this thing, you have to pay for it. So you need to interpret that information yourself. Also won't tell you how important you are. So yeah, no, it's a bit of a joke, but like some people think, oh, I'm using 100 GPUs for my machine learning model. My colleagues are using 50 GPUs, so I'm paying double. But that doesn't mean that your model is more valuable. Maybe you're just really inefficient. On the other hand, maybe it's actually good that your model never makes it to production because it would just consume more, resources that don't produce enough value. So but the thing is, you can't really tell. If you know what you're doing with these services, then maybe yes, you can. So you need that additional context. And then what you really want to be able to do with your bill are things like cost attributions. So you want to be able to relate the charges on your bill back to specific departments or like business units or projects or potentially customers, services that you're running, and break it down by that. Because you might be like, oh yeah, you've used like thousands of hours of this machine type in this region, but maybe they're not all for the same thing. They could be for 20 different things. And you can actually have it broken down like that if you think about that ahead of time and structure your cloud resources accordingly or tag them, etc. But again, whatever you're tagging those resources with or whatever account you're putting those resources in, like that name on the bill needs to mean something to you and you need to relate it back to what your business is doing. Patterns and trends are something that you would probably like to identify. So you may want to like see that there's growth or that you're becoming more efficient, or maybe you've got some sort of Monday to Friday daytime pattern where in a certain time zone your website is busier during the day, so you would expect to have more compute resources allocated at those times. You want to be able to identify those patterns and maybe a trend. And then if you can relate them back to what's happening in your business and you have a forecast on what's going to happen in your business next month, then maybe you can also forecast how much your bill will be next month. And that will make your finance people happy. You also want to be able to easily identify expected and unexpected changes in your consumption. So some changes might be very expected, like a Black Friday sale, or you've deployed a new service, or you've launched a new app. And that's great, but you still want to see how that's affected your bill, and you want to easily identify that and separate it from the other charges. And you also want to see if there's something unexpected, like you might have been hacked, or you might have misunderstood how a certain service works and what you get charged for. So you want to make that easy. And I will show you some examples of those anomalies. But in short, you want to be able to actually do stuff with your billing data more than just, okay, this is how much I have to pay, transfer the money. There's a lot more actionable insight to be gained from your bill. So that's sort of the first point I want to make here. Here's an example of a real customer that we have. This happened last year on GCP. So you can see they spent roughly like 170 to 180K per month on their cloud bill on GCP. And then suddenly in July, it went up a bit to 324,000. So that was a big jump. Then it went down again, actually went down a bit further. So it might be a bit small for you, but this greenish color here represents Google Cloud Storage, which is like S3, basically. So it's storage. Normally, storage doesn't change that much and go back. What do you think might have happened?
They might have not cleared some of their files.
No, so this is like object storage. Like this is more like S3. So it's not actually disks. It's actually like objects in an object store like S3 or Azure Blob Storage or Google Cloud Storage. Yeah, no. So okay, I'll give you a hint. So they were actually trying to save money, and they did something which caused this charge here. No, it's not ingress or ingress. So anyway, they actually knew what happened. So by the time they got this bill, they already knew that this would come. But it was still not intended. So they did this thing. They messaged us straight away. They said, hey, on Friday, I set a lifecycle policy in our archive data buckets, resulting in a $150,000 charge. So Archive, it's like an IoT company. They have a lot of little files in their storage. And they were like, well, we want to keep these files, but we don't really use them much. So, you know how like in AWS you've got Glacier, and in GCP they've got similar like tiers of storage, like colder storage tiers. So they were like, okay, well, let's move this stuff to a colder storage tier. It was about 250 terabytes, so it seemed like it's worth it. And they would have actually made this money back within like 2 years, but that was, still not what they were expecting. It was a bit late because, so with this lifecycle policy, you basically say, okay, any file that's older than a certain number of days or years or whatever they picked, every object that meets these conditions, set it to a different storage tier. And what happens when you do that? It's basically what they call a class A operation. So you pay like for an API call basically at the rate of the new storage tier that is being moved to. And yeah, it was only 250 terabytes, but like I said, it's an IoT company with really small files. They had 3.3 billion of those. And that's what caused this $150,000 charge. So, the thing is, like, it happened, right? Like, so we said, yeah, okay, you could turn off that lifecycle policy. So if, there are more files that might hit that limit, they won't cause you more charges, but it happened. And we verified it was all correct, right? But, and you can also see they were actually saving a bit of money later. Just so you don't get too worried, we have good relationships with the account managers at Google, and this was an important customer to them. So you can see, even though in August they consumed another 150K, we actually only charged them 27K because I don't know exactly how they calculated this, but they were able to negotiate with Google this credit, which we passed on in full of $132,000. So they were actually lucky. But the thing is, if they hadn't noticed straight away that they had done something wrong, and maybe they wouldn't have been able to get this. Anyway, that's like an anomaly where it was sort of expected but not intended. And what can we learn from that? I think the first thing is you should really understand your cloud service pricing. Like if you're trying to, especially if you're trying to make a change or optimize, right? Because sometimes it's not what you would expect. So read the documentation really carefully, or ask your CRE like us, or ask your cloud vendor directly. And yeah, so these services often offer savings options. Like in this case, they've got these colder storage tiers, but none of these savings options come for free. Like there's always some effort involved and some caveats in terms of other things you may be charged for. Like in this case, there's a minimum retention period. You get charged for every object that changes storage class. And there's a few other things. Same with if you want to save on compute, if you use spot instances, they may be preempted. If you're doing a savings plan, well, you've made a commitment to actually pay this money even if you stop using it. So understand those savings options really well before you decide to optimize in that way. Also understand that these services are priced in a way to actually reward good behavior, because that's really the only way that they can control your behavior. Pricing is the only way that they can encourage you to do one thing over another. And in this case, they don't want you to make 3.3 billion API calls. They'd rather have you zip up those files into fewer larger files and then maybe change the storage class. And penalize less desirable behaviors, not stop you from doing them. Like in some cases, yes, there are quotas, but they don't really want you to stop doing things that you might really have to do. But they don't want you. They don't want you to just abuse the system, so they will penalize you. And yeah, discourage the abuse of, which is essentially a shared resource. They don't want your actions to impact other customers. So I noticed in Singapore, there's actually the government has done a similar thing. Can anyone think of what they've done to encourage people's behavior through pricing of certain shared resources? I mean, there's lots of examples, but there's a famous one. Fines. Yeah, definitely. I mean, there's fines and taxes everywhere. And yes, yeah, I wasn't thinking of chewing gum. No. Yes. Very good. ERP. So I think this is a very excellent example. Even though, in order to drive here, you need to have so much money anyway. Like it doesn't matter. Like you can afford to drive there like 5 times a day. But still, people learn. They're like, oh, they're charging me because maybe I shouldn't just drive there without thinking. I should think about maybe driving through these gantries at another time when it's less busy, or maybe go a different way. But they want to make sure that people who really need to go to that place at a certain time that they can go there without being like, slowed down by too much traffic. And that's exactly what the cloud vendors are doing. So, maybe try to understand cloud service pricing from that point of view. All right, another example, this time on AWS. Again, storage, I'll keep it quick. Here we can actually see one of those patterns. So there's a bit of a Monday to Friday pattern, and this orange thing, these are API calls as well. And our customers, they get access to anomaly detection. There was actually a warning logged for this customer. I'm not sure what happened, if they saw it, if they ignored it. Maybe they thought, okay, it's $74, whatever, it doesn't matter. But this was early in June. Early July, their finance person got a bill. And they said, hey, our billing for June shows a $3,000 increase compared to May. And we suspect that it's got something to do with the S3 API. Can you please help us find out what's going on? So, obviously we can drill down a bit further. And we discovered that the specific SKU is the USW2 request tier 1. Don't you love the SKU names in AWS? Right, yeah. So anyway, USW2 stands for US Southwest 2. And these tier 1 requests include like put, copy, post, and list requests. And those are the HTTP verbs. But more specifically, what we saw was sometime between 9 a.m. and 10 a.m. UTC on the 6th of June, 2 years ago. The put object request ceased, and then instead they had a lot more of these list all my buckets, initiate multi-part upload, and complete multi-part upload requests. Has anyone dealt with these, with the S3 API? Anyway, basically every time they upload a file, instead of uploading it in one request, they now have 3 requests, and since you get charged for each request, so now that charge went up like 3x. And then so we explained it to them. The finance person engaged their developer and said, oh yeah, probably because he looked at the CI/CD log and whatever. We upgraded the SDK. We're using this node package, and they discovered a config option which they said they would change, and they weren't in too much of a rush. They didn't decide to roll back or anything, but a few weeks later they made that change and the costs went down again. So what can we learn from that example, or both examples really? I would say you should treat your cloud charges as a metric, just like any other sort of metric that you're monitoring. Whenever you deploy a change, you probably watch out for how it's affecting latency and throughput and stuff like that, error rates. Do the same with your cloud charges. Because, well, first you need to know your baseline. You need to know what's normal. And then when you make a change, you should think about how that might actually affect all those metrics that you're monitoring, which I'm saying should include your bill. And then when you deploy it, maybe straight into production, maybe into another environment first, actually verify your hypothesis through close monitoring of those metrics. Because you won't know when to be surprised if you don't know what to expect. So if you don't know your baseline, well, you don't even know if it's gone up or down. If you don't have any sort of theory about what might be affected, you may not know where to look. So the more you actually define, the more clearly you define your hypothesis, and the closer, then you can actually monitor it a lot closer. From time to time, you will be surprised, and I think that's all right. You learn stuff from it. Occasionally, small surprises are not bad, but if it happens all the time, you just have to think about what you want to do. It's different for everyone, but if you feel that it's happening too much, maybe review, have a discussion with your team. So yeah, it's a secondary metric because you're probably already looking at a lot of the metrics, like how many API requests you've got and stuff like that. And you could theoretically calculate the charges from that, but it's good to verify the actual charges and make sure they match what you're expecting. All right. So just to summarize, your cloud bill is an abundant resource of useful metrics beyond just what you have to pay. I do recommend you monitor it closely and continuously, and understand how it is impacted by various internal and external events like deployments, but also like external events like Black Friday sales or whatever. And make it as useful as possible for your own purposes. So for example, if you can tag your resources or structure your cloud projects in a way where it's easier for you to identify how you can relate the various charges back to business units or projects or customers or web services or whatever, the better. So, and yeah, it does help you identify opportunities for optimization, but act with caution. There's always nothing ever comes for free. So think about what you want to optimize. So yeah, but it's a great way, another way of looking at what's happening in your business. Often it's the only way that we have, the only thing we can see as resellers is what the customer's paying for. So it's actually quite fun sometimes to look at, okay, I wonder what they're doing with these services. Right? So, but even if you do know what you're doing, it's good to actually understand what it's costing you. Now I want to talk about other costs, because in many cases, your cloud bill, yeah, it's like a financial thing and it's important, but there are a lot of other costs when you're running your business in the cloud. And I would like to start by talking about costs to your customer experience. So what are some costs to your customer experience that you can actually influence in your roles? I would say downtime, outages, stuff like that, right? So to prevent those, you may actually have to spend a little bit more on your cloud resources. But as SREs, that is something you can impact. And if you can minimize those downtime periods or outages for your customers, then that's reducing that overhead for your customers. You will keep them happy and successful and productive and able to achieve their goals whenever they want to. Same with like low responsiveness or slowness from the customer's point of view. If you can improve performance, that will actually make your customers more efficient, and their costs will be reduced. And potentially, you can actually charge your customers more because you can increase throughput. Perceived errors, and I'm saying perceived errors because sometimes it's not an error from your point of view, but let's say it's too slow and the customer gives up. It's an error from their point of view. They weren't able to achieve their goal. That's again a pretty bad cost to your customer experience. Unnecessary interaction. So anytime they need to retry or you ask them to enter, like it's more of a usability issue, but sometimes performance can also affect usability or downtime or slowness. So anytime the user has to like hit refresh or something, that's a cost to their experience. And finally, and you should really avoid this if you can, data breaches. I mean, that could actually be a massive cost. You might go out of business, and so may your customers. So massive cost to the customer experience. So really, any sort of unexpected or undesirable behavior from the customer's point of view, I would consider a cost to them that you actually want to minimize if you can. Now, you may also think, hang on, employees are impacted exactly the same way with internal systems and also with dealing, when they're dealing with customer issues like this as well. So both customers and employees, they're people that are like actually very, very scarce and valuable resources, and that you want to minimize any sort of impacts on and keep them happy and productive. Also, especially in your roles, it's also part of your job to actually minimize this for everyone. And there's a cost to it, so it's always a trade-off. But I would say you need to come up with a way to do it sustainably, do it proactively where you can predict like things that you really want to prevent, and make sure you actually test that properly, but also reactively, because you can't do everything, you can't predict everything, and even if you predict some theoretical scenario, sometimes things only get prioritized when they actually happen, or when you observe some sort of trend where, let's say, a service gets slower and slower, or the requests keep going up, and you need to do something at that point. And do it continuously, because you'll never be done. There's always new things to do. And also adaptively, because your customers' expectations change, but also the cloud changes. So it's not like, oh yeah, I've got this server under my desk, I'll never upgrade the operating system, I'll never patch it, I can just keep running the same version forever until the server dies, which hopefully won't be in my lifetime at this company. But with the cloud, you can't do that. Like, things change all the time. You have to adapt to it all the time, and that's part of your job. So you need to actually be ready for that too. Okay, so really quickly, in your jobs, running technology businesses, there'll be some important questions that you will ask yourselves regularly, hopefully. And hopefully the answers to those won't actually change too much. But I'm just going through this, and I want you to think about how those would affect the costs, all of the costs, your cloud bill and the other costs that I've been talking about. So one is a common one. Oh, should I change clouds? Should I move to another cloud provider? Should I go multi-cloud or should I go single cloud? Should I move this workload from over here to over there? Why? Why? So just ask yourself why. Do you need to do it due to regulatory requirements? In that case, yeah, you might have to do it because let's say you have a new customer in a country and your current cloud doesn't have a region there, but they really need to keep their data in that region. Another cloud might offer a region there. So you may be like, okay, I'll deploy my workload in this other cloud. And then if I really like that other cloud, I might even move other things over as well. Or do you expect benefits from mixing and matching features and services across clouds? And yeah, we do have customers like that. Or conversely, maybe you want to bring everything back into a single cloud because you see benefits from the tight integration between services. Do you want to simplify through standardization? Or do you want to give your developers a lot of options of services to choose from? And this does happen. Do you want to take advantage of promotional credits? You know, you might have a salesperson call you from another cloud vendor and say, hey, come over to move your workloads over to us and we'll give you $100,000 credits for the next 3 years. And then you'll be stuck with us, or you'll have to find another cloud vendor to offer you the same thing. Or even if it's to save some money some other way. I'm not saying don't ever do it, but you know, probably don't do it just for that reason. So be very clear about why you're thinking of doing this, because there will be all these costs that we've talked about. And it's not just, you may save money in one area, but there'll be costs in other areas. I also want to say something about SLAs, because people are like, oh, well, if something goes wrong, I've got an SLA, I'll get my money back. But it's not that easy. SLAs are different for each service. Let's pick storage again, because if you're running Kubernetes, you may not be using too many cloud native services, but a lot of you will be using S3 probably or something like that, because you do have to put your state somewhere, probably not on a local volume. Does anyone know what the SLA is for S3? I knew somebody would say 11/9, but please read the SLA. And I know why you're saying 11/9. I've heard of that. I know it's a design goal, 11/9 of durability. But have you, if anyone's ever read any SLA, there's no SLA on durability at all. They don't ever guarantee any sort of, they don't protect you against data loss in no way whatsoever. Sorry, they don't. Disks S3, nothing. The SLA is actually just about, can I call the API? It's just about, it's an uptime SLA. And then for S3, I think it's only 3 nines, or maybe 3.5 if it's, I don't know. But yeah, I think it's 3 nines of being able to call the API. So if 99.9% of the time during a billing month, you can call the API, they've met their SLA, even if, you know, you don't actually get back the object that you wanted. Now, I know they're pretty good, but just understand your SLAs. And yes, and then if they are like, okay, well, if it's only 99.7% of the time, you get back like 10%. 10% of what you spend on your S3. That doesn't make up for any of your, you know, stuff. So yeah, there's plenty of exclusions, and they're not explicit. You're thinking like, oh yeah, I'm paying for storage. Surely there's some SLA on, you know, to protect me against data loss. It's not. It will, even if there was, it will not really protect or ensure your business continuity. Even if you got back like 100% of what you paid for that service, your business may still be gone, you know, if you lose all your data. So don't want to scare you or anything, but yeah, SLAs do not protect you. So be very careful if you're selecting a service based on like a sort of high level cursory reading of your SLA. Like 3 nines, yeah, sure, theoretically worse than 4 nines. And I would say there's a little bit of a benefit when you're comparing, let's say, two database configurations like a multi-AZ versus a single AZ RDS instance. Sure, the multi-AZ has a higher SLA because it's probably true that it's slightly more reliable, but yeah, it doesn't protect you. You know, it's not really a way to ensure that you're not losing money or anything like that. So yeah, read them very, very carefully. And now finally, there's a principle which according to ChatGPT is from the Ming Dynasty. So I don't know if it's actually true, but I like the principle, even if it may be made up, but it's called holding on to your rice bowl or sticking to your rice bowl, like 守住自己的饭碗, I think. So your rice bowl representing your livelihood, what's in front of you. And I think that's a good principle, but yeah, how far do you want to take it? Like, do you just want to leave your legacy apps as they are and where they are, like on a VM with local storage forever, because it's been successful so far. Or maybe, you know, you're Kubernetes expert, so for you, your rice bowl is Kubernetes. So containerize everything and run it all in Kubernetes. Maybe that's good for your resume for sure. And then you want to go managed or self-managed. I would say don't go managed just because you can, but also don't go self-managed because you don't want to understand the technology. So, you know, like let's say you need a Postgres database, just because you're running it on RDS doesn't mean you don't need a Postgres expert anymore. It's quite the opposite. You really need to understand what the service does and doesn't do for you and what the limitations are. But yeah, so I guess it's a trade-off. And then, or do you want to go fully serverless, which is probably not holding onto your rice bowl, but you might say, okay, actually my expertise is in my business logic and the infrastructure requirements aren't that complicated. So yeah, maybe I'll go fully serverless, or at least for some services, so serverless may make sense for me because I can focus more on the stuff that's actually really important, like the business logic. And yeah, this is a bit of a joke. Get an AI to rewrite your code and fire your developers. Don't do that. But yeah, I guess you need to find the right balance, and all of these sort of options will affect the different costs we've talked about. So while I think it's a great principle to hold on to your rice bowl, there's another saying we have in Germany. It's called über den Tellerrand schauen, looking beyond the edge of your plate, because like, I don't know if you've heard of the frog down the well. Like, you don't, like, yeah, the frog might be quite happy down there because it doesn't know what else is out there. But yeah, find the right balance. Maybe one day you do need to get out of your well. So at the same time, don't just chase the latest trends and use AI. Yeah. All right, finally, TCO and cost optimization. I'll tell you straight away, I don't like the way those terms are used. I have used them myself, but they're often misused in horrible ways. So total cost of ownership in the cloud, well, you don't really own much. You don't really own any physical infrastructure. You really, the only thing you might not own is like your IP and your data, your reputation. Maybe you've got some sort of contracts with your customers that you could call ownership. I don't know, but yeah, there's nothing total about those calculations. Like, yeah, like cloud vendor A might say, hey, run it on our VMs instead of these other VMs, and they'll be like 10% cheaper. But that doesn't take into account all these other costs we've been talking about, and the opportunity cost of, you know, not investing their time into something else. So I think it's quite an outdated misnomer the way it is being used by the cloud vendors. But I did think it was related to this topic. And similar with cost optimizations. Like when cloud vendors talk to you about cost optimization, what are they talking about? And what are you, or what do they think you want to actually optimize for? The long-term or the short-term cash flow? Like, I mean, we saw the example, yeah, 2 minutes, yes. Change your storage to a colder tier. In the long run, that might save you money, but can you afford it in the short term? Also, same with like, okay, do I go serverless and save some development time versus build something else that might take me a bit longer, slower time to market? So that's one thing. Or is it the customer experience, their satisfaction and success, or your employees' productivity and happiness and efficiency? Is it compliance? In some cases, you don't really have a choice. You have to build things in a certain way, even though it doesn't make sense to, you know, meet a certain requirement, like if you're in finance or something. But those things are important. So just be clear on what you're optimizing for when you say cost optimization. It's not just, your bill is important and there are plenty of opportunities to optimize, but it's not the only thing. So yeah, I know I just said TCO is not the right word, but yeah, you need to look at the overall costs and find the right balance for yourself. Okay, so again, same with Joshua, we'll do questions at the end, but thank you very much. And I've missed the beat. What are we doing with the, can I disconnect now?
Yeah, you can
Yeah, okay, cool.
Hello.
Hello. Yeah, thank you very much. Now we have a third speaker. So we can continue. Thank you. Okay, so I would again repeat with the guys who are online on the Zoom that after the session of Praveen, please stay tuned for filling up the feedback form. I would be giving away for 5 people $40 Amazon vouchers. So just stay tuned and we will let you know how to get it. Thank you. Over to Praveen. Thank you. So, and the last one for you from this meeting, this is not the best time to speak, but I hope you guys can, continue this conversation. So I want to make it a little interactive. First, let me introduce myself properly. So my name is Praveen John Kumar, and I'm a regional architect with Sumo Logic. And in my years, I've worked with different clients across the region, helping them with cloud adoption, technology adoption, as well as working in consulting, as well as helping them with architecting solutions. So happy to share this, continuous intelligence. What is it related to, and how do we do that for Kubernetes, right? So as I said, starting with a little bit of quiz. There's no gifts, by the way. So you can clap if you get your answers right? So who wants to go for this one? So Google spins up around 4 billion containers a dash. That's not the, that's one of these options here, as well as that's over 6,600 containers every dash. Who wants to take a guess? Week and days. The first is right. In seconds. Right? All right, next one. What is the predecessor to Kubernetes? K7S? Boring. Yeah, simple, right? Okay. An abstraction in Kubernetes which defines logical set of pods and a policy to access them is it deployment? Is it service or no? It's like a logical segregation of your application by what is service, like network, stuff. This should be the easy one. Kubernetes is written in Go. Perfect. So you can all clap for yourselves. You guys got the answers right. They're also answering. Oh, okay. Okay, so that's good. People are listening there as well. Right, great. So yeah, so let me start by giving a little bit of overview and then just quickly go through that and go into continuous intelligence. So Kubernetes and container management, right? So the evolution of modern applications, as you all know, has not completed. It's still happening. You still have a lot of applications who are in three-tier architectures where you have the data of your customers running in databases. You have the logical processes, business logic sitting in the business layer, and your user UI and API needs a framework that is running on the application layer, on the presentation layer, sorry. So that could be a typical services that is running, right? Yeah. And as we move towards a more complex application, because we are migrating towards, let's say Netflix, for example. So you have more than 88 microservices, even for a single payment service. Did you know that? And that's the kind of complexity that you are dealing with right now, right? So which leads us to be able to deploy and monitor and manage as you can scale your applications. And that's why you have Kubernetes and all the other systems that you have. So, the portability of the application that we just talked about with microservices is solved by, in the first week when you're developing an application, that's solved by Docker, right? Most commonly used container orchestration. So what do you do for the rest of the time, right? The remaining 8 years, like a golden period in which the applications are running. What do you do with that? So you use your container orchestration solutions, the most common being Kubernetes, right? And there are a lot of challenges that arises with that kind of scale and management as well, right? It could be saying, how do you actually start failovers? How do you know what's happening within your application? So how do you bring in intelligence into your management of containerization? Okay, so that's where we will be focusing deeply on. So from all these container management solution, I'll be focusing on something which is common across all of them, so that we, whether you're using Amazon, Google, or you're using your own, OpenShift, should be still, advisable for any such Kubernetes management solution you're using, right? How many of you know what is continuous intelligence? Okay, so it's good that I'm speaking today, right? Otherwise, I just go back, sit down. Okay, so managing Kubernetes is challenging. It's one of the easily set skill gaps that we have in organizations. When we go and talk to different consulting groups, where we identify what is the major challenge that they have in organizations at this point within SRE teams and DevOps teams, having the skill set to manage your container orchestration, how if things go wrong, even if it is, I said, it's a managed Kubernetes deployment or self-managed deployment, how do you actually get that skill to focus on improving the business operations with managing containerizations, right? So if we go further down, the common challenge that you solve by managing container orchestration is having offloading that to a team called a SRE team, right? So half of the time, what they do is they start working on operating to request of scheduling for the different business units, and as well as the other 50% of the time doing orchestration as a code, right? So formation templates, Terraforms, or even automating using scripts to make sure that you can solve this, where they can focus on creating business insights on what is my business deploying this month? How do I actually optimize the resources within the deployments of the containers? How do I get that to an optimum level so that I know if there is anything going to be going wrong, or if there is any threat actors who are coming into my platform? So all that thing is quite difficult for a SRE team to understand and do as they are managing the operations, right? The amount of people who are managing this is not going to go up as the complexity is rising. It's going to go the other way. How do you do that in managing? That's where continuous intelligence comes into play, right? So continuous intelligence is more of a design pattern, I would say, in which you're using real-time analytics, which again is a buzzword, but if you understand what we are talking about, is to integrate the business operations of your various business unit, and by processing the current and historical data that you're collecting from the systems, and prescribing actions of what you would do in various events, right? So the most common events that you would think about could be, how do I manage security? How do I manage if there is a performance degradation, right? And you could also ask questions around, how do I analyze this from a time scale perspective? What's happening now versus how do I predict what's happening a couple of hours from now, right? And this reduces the friction between the value that you're getting from the data that operational team generates to turn that into insights or intelligence per se, right? So is that a business task or is that a technical task? It's actually a combination of both. So if you are a technology person who's focused on understanding how container works, how do you do orchestration, how do you get deployment successful, how to automate that, fine. How do you then add value to your business? How do you optimize your business operations with your knowledge on the operational perspective that you have? So that is where the continuous intelligence comes in, where you can use the real-time analytics on the data that you're generating from the management of Kubernetes container orchestrations to then derive business insights out of it. So that's what we will be focusing on today, right? So there are some key recommendations that are here. It's particularly 4 that I'm focusing on. with interactions with most organizations, where you're speaking to helping them achieve continuous intelligence. So those comes into security and governance, monitoring, DevOps, and AIOps. So let's go about all these 4 best practices on how do you use your operational knowledge as a SRE, as a DevOps, as a developer, then use that to improve your business value for your organization, right? So it's quite simple. So let's focus on the security and governance, right? So from an operational perspective, you could be doing a lot of things. You want to improve innovation. You want to make sure that you have multiple people who have access to your container orchestration service. You want them to be able to provide automation as a code so that your developer team, like imagine that you are a SRE team, you want your developers team to be able to figure out automation to deploy and create new pods, auto scale on automated basis, right? So if you want to add additional business value to that, is what does a business user think about? Is to make sure that whatever you're doing from container orchestration is it secure. How do I govern that? Right. So what is the operational skill that we can add in to make sure that we are able to improve the security as well as governance of the operations, right? So there are 4 key recommendations that I'm talking about, which is what we speak to most of our people that we speak in this space, is cloud control plane. When you have your access to different orchestrations like self-managed, or even if you're talking about Azure, so we want to make sure that you have privileged access to be controlled. Right? So you want automation, you want to make sure that this managing of containers, automating using infrastructure is there, but you need to be able to provide a privileged access control method of doing this. The second thing is, as you're focusing on automating and doing raw container management, we need to focus on, at the end of the day, it's running on Linux kernels, right? How do you constantly manage the security of the operating system which is running? Are you using that into your orchestration? That's part of your SRE team. You can say that I would sideline that to a security expert, but that doesn't add business value. How do you improve that continuously? So you use solutions which help you to do vulnerability scanning. How many of SRE team here use security penetration testing as part of your role? You interact with them? That's good. So which is where you would identify the patching requirement as to if there is any vulnerability, how do you patch that, right? So that's a key thing to consider. I'm an SRE, I don't need to do that, but how do you add value to your business by making sure that you are protecting what you're managing, right? That's another thing. The third aspect of security and governance is authentication and authorization. Do you have multi-factor authentication for your administrators to be able to manage it? Do you know who accessed your containers as you're making it automated? How do you control that? You don't want to make it friction-proof, but you still need to make sure that it's authenticated and basically authorized based on the level of access that they need, right? And the last being cyber threat. Behavioral monitoring. Now that as you adopt your SRE practices to make it more continuous, seamless for your business consumers or your end consumers to automate all the deployments, how do you identify behavioral monitoring, right? How do you validate what is known behavior, and how do you understand if there is an anomaly, right? So that is where you would work closely with security on governance within an organization, where a Kubernetes managing team or container orchestration team expands the portfolio to add business value to it, right? So these are top 4, not saying that these are the only ones that we should focus on, but adding continuous intelligence to your Kubernetes, focus on first thing, security and governance, right? These are 4 key areas. And second thing being monitoring. Everybody does monitoring as part of SRE, so container orchestration is being monitored. And the focus that I would recommend here is open telemetry based monitoring. How many of you have known what is open telemetry? Raise your hands. Almost like 20% of the folks. So I would like this to be 100% of us, right? Because as a Kubernetes user, as a part of Kubernetes user group, we would like to be able to provide visibility to what's happening, not just on the container itself, but what's running on the container. That could be an app security problem, but if you don't focus that from app security versus a container security, there could be gray areas that you'll be missing, right? So when your open telemetry comes with various aspects that you would like to collect on, which is logs, could be metrics, could be traces or events, right? I'll be focusing on a few key areas here because there is a lot of areas which would like to be monitored. I'll focus on a very specific information about auditing. How many of you use auditing in Kubernetes? Auditing events. API server, we have audit policies. How many of you monitor and use audit policies to manage Kubernetes deployments? No? Okay, so that at least I would have something to share with you here. So the API server, imagine it's like a grand central station where everything from container orchestration as you go to say deploy a pod, unprovision a pod, or break down a pod, everything goes through API server, right? So you have audit policies in there which can actually help you to monitor any event that's happening. So if you look at it, there are 4 audit policy events that you could do, which is request received, response started, response completed, and panic. Those are 4 events which you can actually monitor. And there are audit levels in which you can monitor that per se, which is none, just take the meta information of that, or even you can dump the request or even request response for that matter. And you could actually send it to your logs, like from the event, you can log it. If you have an existing open telemetry, you could be using any solution. There's no solution recommendation here, but you would want to make sure that you have events monitored, and you could convert it into logs. You can send it to an API via a webhook, or you can even do a dynamic conversion into metrics, for example, right? So just a sample here, screenshot. Maybe it's not very clear, but it's a screenshot of an actual request received monitoring event, right? This is one of the 4 open telemetry data collection that you could do: events, metrics, traces, and logs. So if you could be using open source tools to do the monitoring, or you could be using proprietary tools to do that. But make sure you use those audit events as part of your configuration, because this is operational knowledge. An external monitoring expert wouldn't be able to do this for you. But you could add value by providing business intelligence or continuous intelligence to your application and your organization by providing that feedback. The third thing that I want to focus on is DevOps, right? So usually that's something that previously used to have DevOps teams, and platform engineering teams, SRE teams, container management teams, but DevOps, I don't think it's a team. I would say it's a concept. It's a way in which you actually start to align with, as I said, security. You will align with your developers, right? Meaning you understand what's being developed, why it's being developed, why it's important, why do they need to do that certain way. You could even make recommendations on what needs to be done. So focusing more on continuous integration. How do you actually be part of the continuous integration flow, and then do a deployment analytics as developers do their testing after deployments? Thus, our SRE team, container orchestration team, Kubernetes managing team, do you do deployment analytics? If you want to do it, how do you do that? You could use your monitoring solution just now you spoke about, and focus on integrating that data that you come from deployments, and start managing that to see if there is any optimization that's possible, right? So it's more of wearing not just the operational hat, but understanding that your exposure is more on providing value to your business for all these aspects. And DORA is metrics that you could use to do this from DevOps perspective. Google shared this knowledge out with the community. So there are 4 key areas which we can focus on. One is your deployment frequency, how often you do that, and how can we improve it if it needs to be improved. And then the lead time for any changes. Is there any inherence in terms of deployment orchestration or developments or an operation perspective? how can we focus on reducing that? And the third being change failure rate. If there is any, deployments that you're doing, how much of it's failure? How do I make sure that I could go towards a continuous improvement route? And the last being time to restore that service. So that's an afterthought most of the time, but have you practiced the disaster recovery? And how could you improve on that disaster recovery by doing simulated deployment recovery from container orchestration perspective alone? It's not an application problem. It could be a container deployment problem too, right? For that instance. So we did cover about SLI, SLOs from previous topics too, but that's something that you should focus on. It could be any SLI, service level agreements that you have. That's internal. It doesn't have to be the ones that you have with the customers. What is the key KPI that you want to improve? It could be saying number of good events versus number of bad events that's happening. And are we tracking that? And how do you make sure that that is presented and how that is improved upon as a part of the KPI, right? So this is some of these coming from, things from Google per se, and the others are some of the experiences that we gain over years, right? So that's the third aspect. So security being the first one, and second one being the monitoring aspect, and third being DevOps. And the fourth and the last one is AI Ops. So which is where, as we're focusing on bringing the operational knowledge into improving the business continuous intelligence of your operational environment, start leveraging machine learning patterns. I'm not asking about like ChatGPT, all the fun stuff and doing generative AI to do automation as code. Just start with the simple stuff. Are you able to, identify the patterns of changes that are failing? Is there any active monitoring that you could set up that provides you with machine learning and sharing with the team on what is the failure about? That's all is machine learning and artificial intelligence. Is the system with a simple way, identifying, running through all your failure data, identifying and running through all the security alerts that you've created, running to the device access that is being used over the time. Can you correlate all of these and then come out with the results? It could be a simple Python code that you could write, because all of us are an SRE focused, developer focused Kubernetes team, right? So when you do that, you will be able to use simple artificial ML language to predict and also identify if there is any patterns that you could see emerging. So if your program could do that, you have written an AI, right? That's where you start. You don't have to start where I need to have a data science team that needs to give me all the inputs with different parameters. If you start doing all those three that we mentioned before, you could now automate that. When you automate that, system is deciding it for you. And the system is telling you what you could do. And that's artificial intelligence in its base form, right? So you could use some of those to solve your challenges, and you could start exploring some of the commonly available libraries, which you can start to use that. And what are you trying to achieve by this is you could potentially start towards fixing problems using automated application. So we know self-driving cars, self-correcting data centers. Some of the cloud providers use that. You could do a self-correcting deployment orchestration. If there is a failure, how do I recover? Kubernetes can recover, but there are certain aspects of your operational management which you can actually improve and enhance. And that could be an automation, simple automation, or if you're using your continuous integration tools that you have as a part of the system, then you can actually use that to start fixing issues. So you could have a self-correcting systems that you have developed. So not only focus on automating deployments, how to automate correction, how to automate identification, how to automate improvements. So once you start doing that, you're focusing on continuous intelligence, where you're coming back to the subject of what we spoke about initially. Make informed decisions based on insights, right? So once you start doing all these recommendations that we shared today, you would be starting to focus more on infusing your business process and continuous intelligence to personalize the interactions that you're having, streamlining the operations within your container orchestration for Kubernetes, and also proactively fix issues before they even arise, because you're focusing on identifying, monitoring, and governing and controlling the right privileges for each of them, and ultimately improving the performance of the organization, the business unit, and the company. Right. So just a quick recap: continuous intelligence is not a buzzword; is using analytics to solve continuously your operational problem, thereby improving business performance. Right. So there are 4 recommendations I made, but that could not be the only few because of the time. But focus on those 4. But there would be more that you could start to focus more deeply on each of those contexts to add more value to what you're doing. So thanks for the opportunity, and this is me. Thanks for listening.
Great question.
Should we all 3 show up?
We can just stand up. Whatever questions are thrown at us. And how does it work with the private?
Oh, okay.
Oh, we ask questions.
Oh, we asked.
Ah.
We-
can ask or they can ask.
No, you guys asked. Do we have somebody to run with the microphone?
Yeah, there.
I have one over there.
The question for you,
Oh, thanks.
so you said the archive data, made the bill huge in between, right, in the graph.
Mhm.
For the line. So what did you guys, or what did they do to reduce the bill in the next one?
Oh, okay. Yeah.
Or next day, or-
Yeah, no, it was not the next day, but so the customer discovered it the next day that the cost was not like a lot higher than they had expected. They didn't really. Anyway, so basically our technical account manager spoke to their peers at Google Cloud, and this customer happened to be important to them. They had a commitment. They were, a startup with a lot of growth potential, and they explained it was an innocent mistake.
So
And
pulling a
they-
string. So pulling a thing, there is no technical solution to get back to the century.
Well, there's no technical solution to getting money back that
How is
you've
that?
already been charged.
At least recover from it, like unarchive or how to do it.
I mean, so
It's a continuous bill, right?
so you could no. So that's the thing. So it wouldn't have been continuous. So once you've archived your data, or once you've moved your data from a normal storage tier to a colder storage tier, you do actually pay less for the storage of the data itself. Like every month per gigabyte, you pay less, and so they did actually achieve that goal. It was just that they hadn't expected that one-off charge to be that high, because they happen to have 3.3 billion objects that this policy immediately applied to. And there's a charge for the change of the storage class for each object. It just happened to be very high in that month. And yeah, we just asked very kindly, and Google was, they just felt sorry for the customer, I guess, if you wanted to put it that way. But yeah, they do care about their customers, and they said, okay, we'll give you a credit because it was an innocent mistake, and we passed it on.
Is there a way around this in the first place? I'd say if you want to put it the right way, you want to make it cold, but for the class A operation. Is there a way?
Yeah.
Or-
Well, not in bulk, not exactly like that. I mean, how would you avoid it? I mean, yeah. So like, I think I did actually suggest you could potentially zip up the files, like if combine, like, let's say, because an object in GCS can be up to 5 terabytes, but they had 3.3 billion objects that made up 250 terabytes. So you can calculate, I don't know, like they're like a few kilobytes each, or maybe less, like on average, right? So
You would reduce the number of objects. And that's
In-
important.
in that case, yes. Or, maybe the other option, or maybe a combination, would be to delete the things that you don't really need. And then, yeah, combine the objects that you do want to keep, and then move them to a colder tier. You could also consider writing them to the colder tier straight away. Like, you would still pay for that, but it wouldn't be like this one-off massive charge. It would be an ongoing thing, and you would start saving straight away if it was pretty much for archival purpose from day one, and it's very unlikely that you would ever access them. You could potentially consider that. So yes, it would still cost you more upfront when the object gets generated, but it wouldn't be this massive charge in one hit. Yeah.
So you mentioned that continuous intelligence is
Oh, thank you.
you mentioned continuous intelligence is not exactly buzzword and like people are working on it, but how do you see in the market companies or teams hiring for continuous intelligence like data science or AI experts, or they are first building it themselves and then maybe they'll look forward to more experience?
Yep, sure. Thanks for the question. So it all starts with first is intelligence first. So organizations as they mature, so they would start from reacting to some of these that I spoke about, and then doing proactive management, and then eventually doing intelligent solutions to do using analytics to solve these problems. And if they're doing on a real-time basis, that's why it's called continuous intelligence, because you're using real-time analytics to solve that. So some of the customers in digital native businesses, like could be the fintechs or the cryptos, those are the ones who are actually focusing on it right now. But we see this adoption happening in teams which are led by leaders who focus on bringing intelligence into operations. So this could potentially be a trend that's catching up, because there are systems that are becoming more intelligent, and you can actually use these intelligent systems to then feed that into operations to get business insight out of it. So which is why I see that this is a trend that's going up, and which is bringing down the barrier of entry for people. So even an operations team who don't have a proper data science background can actually start working on it.
Of the extension of that, would you say that sort of an evolution of observability as we know it, almost observability plus data science is kind of what I get gathered from this?
Right. So, from an observability perspective, what business value you're solving is, if I have a complex applications, how do I get visibility? That's observability, right? So the buzzword is O11Y, like K8S, that's O11Y, it's observability. And when you start making things visible and not stop there, but trying to solve the problem of the, improving your application itself, not just talking at visibility, but using it into AI operations, which is where you would start to fix the gap of ITOM, IT operations management, and combining that with observability. That's where you get your continuous intelligence actually solving that problem.
I have one question.
Joshua, thank you.
Yeah. So you mentioned about the CRE and SRE available, right? We're aware about SRE. Actually, I only heard the CRE term on review. Isn't that the same? Like this is you need a high level technical knowledge for being a SCRE, right? Isn't it the same as a system analyst role?
So your question is, if you need a high level of technical knowledge to be CRE, is that the same as system analyst? So, people use terminology in whatever way, but as I understand it, system analysis is to understand an enterprise's requirements and needs, and then interpret that into requirements and a spec. So it's something like product management, but it's first of all based on usually the internal needs of internal enterprise IT. And so it's a different skill set. It's it's more directly focused on the business. Of course, we all need to translate the business to technology. But the systems analyst is specifically doing that in enterprise context. Meanwhile, CRE, as I defined it, is somebody who knows everything, both to do manage about the cloud. Somebody with the expertise to advise experienced SRE. So the SRE people themselves are usually quite knowledgeable and skilled, but it's somebody that they can turn to for even greater breadth and depth of knowledge.
Also, those people are also SRE.
Yeah, I mean, we all have the skills, right, to do these different things, whether it's to manage cloud deployment themselves, to advise other people. Does that answer it?
Yeah.
All right, good.
We have a motion for that. We are flashing the QR code, please, we go to that one.
Just to talk about CRE, you have their experience.
Question, how does CRE build up experience? What I know is how we work, do it, which is very unusual, actually. And we just hire very, very experienced people. I mean, I have 23 years experience in industry, not all in the cloud, but it turns out that when you have worked in enough different technologies, the new technologies are not even that different anymore. You just extrapolate from your knowledge. That requires a lot of experience. So that's different from just saying, I'm going to learn 200 services, which we do as well. Actually, we do that by studying a lot and, learning lots and lots of certifications, which is a different thing from experience, right? So I think I probably gave two answers, a lot of practical experience and a lot of study.
So the reason is SRE for CRE.
So the CREs I know, some of them come from an SRE background, but some come from a product development architecture background, usually with backend. Well, that's what I did mostly. I was an architect in product companies. Okay, so what's next?
More beers. Thank you, Joshua. Thank you, Birger and Praveen, for having us at the wonderful session today. And thank you DoiT for making it happen. So yeah, thank you very much. And we'll move on to
You.
Close 2 minutes.